First of all, I am very much honored and feeling very much privileged that I am the part of your community now. I can say that, yes, now we are contributing something, so I'm the part of your community. So, first of all, thank you so much. And today, before starting the this workshop today's, first of all, I would like to tell about myself. I am Muhammad Harisul Mahasbi, and I am from Pakistan, and I am currently working as a lecturer in COMSATS University Islamabad. And this is a little bit about myself. And now, if we go towards the actual session, my focus is on structural equation modeling with SmartPLS. So why I choose this topic today? Because data analysis is one of the important area, and once we clear those analysis concepts, then it is very much easy for us to conduct a research. And specifically, I don't know what's the situation over there, but in Pakistan, data analysis is considered as the one of the challenging part of the research. So I tried to make this whole workshop as easy as I can so that every can understand the basics of basic concepts of the smart PLS or data analysis through smart PLS. So now, if we start, so my today's workshop agenda is it is basically a 5-point agenda. In first point, so first of all, we will see what is SEM, structural equation modeling, and uh, how Smart PLS 4 looks, that Smart PLS software. And after that, we will go to data import and preparation and model specification, like how we can import data in Smart PLS and how we will build a particular model through Smart PLS. Then in the next section, we will go through PLS-SEM algorithm and measurement model. So this would be our part 3. And in part 4, we will go for bootstrapping and structural equation modeling. And in the part 5, we will actually go for how we will report the results that we have generated through Smart PLS. So, and also there is a question and answer session at the end. But as I have designed it more like a workshop, so I would suggest if you have any question, just raise your hand or interrupt so that we can answer every question in between. So, first point is that what is SEM fundamentals? SEM means SEM, SEM means structural equation modeling. So, first of all, SEM is a powerful statistical methodology that allows researchers to test complex relationship between observed and latent variables. So here our first question is what is observed variable and what is latent variable? So first of all, we'll focus on latent variable, this concept. Latent variable is unobservable concepts like job satisfaction. For example, if I want to know about job satisfaction, then how I will measure it? I will measure job satisfaction through certain statements. For example, I will ask my colleague or I will ask from my respondents that do you like your job? Are you satisfied with your salary? Is the behavior of your boss is fine with you? So I will observe latent variable through these statements. These three statements are called observed variables, and when I combined these three statements, this is called latent variable. So basically in SEM, we measure latent variables through observed variables, and after that we check the relationship between latent variables. So this is the basics of SEM. Okay, so what SEM does? SEM does two things. It combines factor analysis, number one. Number two, it combines factor analysis with multiple regression to verify the measurement instrument and test the multiple hypotheses simultaneously. So it does two things, Sam, basically. Specifically when we do it through smart PLS. First of all, it actually verify the measurement instrument. Measurement instrument means the questionnaire, or you may say the survey that you have designed to collect data from the respondent. So here I have made one assumption that how we collected data or through a survey, we already know about it. So this is my assumption that here the researcher knows how to conduct a survey. So with this assumption, I am moving forward that once we have collected the data, first of all, we verify that data, and after that, once we verify that data, after that we test multiple hypotheses simultaneously. So that's the beauty of actually structural equation modeling, or SEM, that we can simultaneously uh, measure multiple hypotheses. So that's the real beauty. Say, for example, if you have in your model three or four variables and one dependent variable, instead of checking each relationship separately, SAM does this thing simultaneously, and it calculates the data of it actually find the beta value or data of each value, each variable. So that's the real point of structural equation modeling. So now we are clear about structural equation modeling. Then we move towards why we use PLS-SEM. So we will use in today's workshop PLS-SEM through Smart PLS. Although it has other functions as well, there are in Smart PLS. So why use PLS-SEM? First point is prediction focus. So its primary goal is prediction. Like I was saying before, that we have, let's say, number of independent variables and one dependent variable. Now we want to predict the dependent variable based on those independent variables. So PLSM helps us to predict that. How we will does this in actual when I will go to the Smart PLS software. Small sample size. This is another thing that other softwares require a big sample size to work effectively, but Smart PLS only require small sample size. So it can also conduct the data, analyze the data. After that comes non-normal data. Non-normal data means that normality assumption is actually becomes very lenient when it's about using Smart PLS. In other softwares like SPSS, we must have normal data to predict about the population. But here, non-normality distributed data without a strict assumption. That's why we, in management sciences or in a business study, we prefer Smart PLS because its assumptions are very much linear. Now, with linear assumption, it can calculate complex models. Complex model means if you have number of IVs, number of DVs, number of mediators, and number of moderator, it can PLSM can simultaneously run that data, and it calculate the effect of each variable. So till now, my question is that did you get the basics of PLSM? So if you have any question, please ask, or otherwise give me go ahead so that I can move forward. Yes, is my voice is clear?
Yes, sir.
Okay, perfect. So these concepts are clear, so I move forward.
Yes, it's clear. You can move forward to another
Okay,
slide.
please.
Thank you.
Thank you, Anwar. Now, these are the basics. Now I will move towards the actual software, and here we will actually start a new project. And the important point it is, uh, also note this point, that you have to prepare a data file in CSV format. That is important for Smart PLS. So once you are done with this, after that, import the data in PLS and just play the music. Actually, for today's workshop, I have selected this model to work on. This model is basically, here independent variable is supervisor ostracism. Dependent variable is knowledge hiding and task procrastination with the mediation of threat to self-esteem. And individual resilience is moderator. Here actually we are not concerned about how these variables are related to each other. We are more concerned towards that how we will measure. This is the focus, how we will measure this relationship through PLS-SEM. This is the today's actual focus through Smart PLS. So if you guys just take the picture of this model, because we are going to intensively use that particular model for this. So after this, now I will open Smart PLS. So when you open Smart PLS for the first time, this software looks like this. Here, if you see, this is your workspace. Everything you do will appear here, and here will appear all the models or all the projects that you have started. So if you look at the top of the software, here you can see a button which is new project. So if you click here, new project, a dialog box open. It says create a new project. So I will name it like, for example, I name it as RAR test. For example, you can name it according to your project. So I create it. Now you can see here I have created a project with the name RAR test. Now there are two buttons under this project: import data file and create model. So before importing data file, first of all, I would like to show how a data file looks. So uh, I am opening data file. Okay. So if we look at this data file consists of uh, 373 respondents, and this is your IR individual resilience. So here, individual resilience, we have measured this through 6 statements. I am assuming that we know about individual resilience.
Habibur Rahman, camera mute करना.
After that, there comes KH. KH stands for knowledge hiding, and we have collected data of KH with 3 statements. Here, these 3 statements, as I have shown, as I have explained in previous slides, KH means knowledge hiding, and we have measured KH knowledge hiding through 5 statements. These statements are called observed variables, and when we combine these statements, this is a latent variable which is a knowledge hiding, and so on. So now you are familiar with the data file. Now I will show you that we will import this data file to Smart PLS. So I'll just open Smart PLS. Now here you can see a button named as import data file. So data file is already created. So I will just click on import data file. Now I have already saved that data file with the name of test. So I just select that file and open. Now this data is loading, and now the important thing is that you check your data file and it must show that data here there are zero empty values. If values are zero, that means uh, we have imported data successfully. So no empty values. I'll just click on import. The file is importing now. Okay, so now we have successfully imported the data file. Uh, if we look at, it says our sample size is 374. I also shows you guys that we have a sample of 374. Okay, so you may be guys wondering that it shows actually 373. The point is that the case indexes start from 0. So 0 is also counting. So total, if we move towards the smart PLS, total is 375 or 374 sample size, and indicator means that total number of statements means statements of knowledge hiding, statements of individual resilience, statement of supervisor ostracism. All these are total in combination with in 30. So I just go back. Now, as previously we have seen, we have successfully imported our data. Now we will create a model. Uh, if you have any question till now, please ask. Please.
Yeah, hello. If do you guys have any question to ask, please go ahead.
Yes, sir, we can
Yeah, you can
understand
raise
well.
hand. Okay.
Okay. So that's perfect. So now we have successfully imported the data. Now we will create a model. So we just click on the create model. So this is the important step. So we will just click on create model. This dialog box open. Now our project is RAR test and model type. So if we click here, we have number of options. So our today's workshop focus is on PLS-SEM. So I will select PLS-SEM and I will just name the model. Again, I will name it as RAR test and just click on save. I'll click here. Okay, so now our data file is also imported. Now I am ready to create a model. So to create a model, I will move to my slides previously. As I have told you that we will follow this model. This model is actually supervisor ostracism leads to threat to self-esteem, and that threat to self-esteem leads to knowledge hiding and task procrastination. Here, supervisor ostracism is independent variable, knowledge hiding, task procrastination, dependent variable, and threat to self-esteem is mediation variable. And also individual resilience is a moderating variable. So I will create this model in SmartPLS. So I go to SmartPLS 4. Now I have code each statement with their abbreviations, like KH here means knowledge hiding. So if we look at here, our first variable is supervisor ostracism. So I again move to PLS and find supervisor ostracism. So SO is for supervisor ostracism. I'll click here, supervisor ostracism, and it is measured through 6 statements. So I will select all these 6 statements, just double click, drag and drop. So here comes supervisor ostracism and I just press enter. Now supervisor ostracism is loaded here. So I will select and just move it towards the other side. Now, next is threat to self-esteem. Threat to self-esteem is shown here through TP. So I will select TP, all statements. TP is measured through TP means threat to self-esteem, and it is measured through 7 statements. Just double click, drag, and drop here, and I will press enter here. Now TP is also loaded. Supervisor ostracism also. Now next is knowledge hiding and task procrastination. So knowledge hiding is first. Knowledge hiding consists of 5 statements. Double click and drop here and press enter. And after that, uh, task procrastination, I will go to task procrastination. Sorry. TP is task procrastination. TP is task procrastination, and threat to self-esteem is SE. Sorry for inconvenience here. Abbreviation for threat to self-esteem is SE. TP for task procrastination, KH for knowledge hiding, and SO for supervisor ostracism. And after that comes individual resilience, which is a moderating variable. So first of all, we will connect these variables, and after that we will move towards the moderating variable. Okay, so now we can see we have imported all the variables here. Now we have to connect and show their relationship. How we will do this? We will just click here, connect. Okay, so once I connect here, click on the connect. I will select SO. I will double click on SO, which is supervisor ostracism. And now you can see there is an arrow coming because I have clicked on connect. So now when I'll start double clicking on SO and drop it on SE, there comes a green line. So that means SO is now related to SE. Now the color of these variables changes, and if their color changes, that means we have successfully connected the both variables. After that, again, now I have to connect SE from KH, which is knowledge hiding. So threat to self-esteem to knowledge hiding. The same process. I will double click on SE and drop it on knowledge hiding. So again, the color is changed. So we have successfully connected. Now the next is threat to self-esteem to task procrastination. Double click and drop on task procrastination. And after that, now we have successfully connected all the variables. I just rearrange their directions. I'll click on select here, downward. Okay. Now, our moderating variable, which is individual resilience. I will select all these 6, double click, drop, just enter. Let me rearrange so that it look nice. And after that, now as it is IR individual resilience, here IR individual resilience, we can see that it has a moderating effect on between supervisor ostracism and threat to self-esteem. So we will select here button, which is moderating effect. Click here and just double click and drop the arrow here. So if the arrow is showing a dotted relationship or a dotted line, that means here we are talking about actually uh, moderating variable. So now we have created our model successfully. So if anyone have question please ask so that we can move forward. Yes, if you have question, please ask.
Yeah, hello.
Yes,
Is anyone? Hello, can you guys hear us? Do you have any question? Or we can move on.
Yes, sir, you can move. We can hear you, sir. Thank you.
okay,
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 we'll
okay,
just
okay.
continue.
That's perfect. So now we have successfully created a model. Now, when we create a model, as in our previous slides, we were discussing that we do for two things mainly. Like, first of all, we verify measurement instrument, and after that, we will test multiple hypotheses. So, our first task is to check or to measure or verify the instrument, whether the instrument is fine enough or or the data is enough healthy that we can run a smart PLS or we can check the hypothesis. So I will go to calculate here. So once you created the model, everything would be done here on a calculate model. So I will click on calculate. Now there comes number of options and you will go for first option PLS-SEM algorithms means that here you will check the health of your data, whether your data is healthy enough that it can run uh, structural equation modeling or not. So first of all, to check health of the data, I will click on PLS-SEM algorithms. Once I click here, you don't need to change anything, just a dialog box open and click on start calculation. Okay, so once again, I'm showing you click here, calculate, and then you click on PLS-SEM algorithms, and other dialog box opens. You don't need to change anything, just click on start calculation. I click on start calculation now. So calculating. Now it shows number of values here, number of values. So to understand this, instead of going here, I will open report. I click on here, open report. Now the report is open. Now I will click on, first of all, outer loading. So if you guys are making any notes, so first of all, keep in mind that when we go for PLS-SEM algorithm, first of all, we click on outer loadings and check whether our loadings are fine enough or not. So PLS-SEM has mostly has three colors. It shows data. It shows data in green. It shows data in black or in red. If the data is in red, then that means that we need to look at this particular value. So here we can see all the values except this one, all other values are in green. So what does that mean? That means all our values are fine enough except for IR6. So now here PLS said two things. It says either we need to collect again, either we need to collect the data again for IR, and if we don't want to do this, then we have to delete IR6 because it is not loading properly here. So here, if we see only the value of IR is in red, all other variables are fine. So we will delete IR6. So I'll go again to graphical output here and I will find IR6. IR6, see, is showing 0.585 and it is in red. So I will delete this. So I have to go back and now I will delete this. Okay, now it's deleted. Now I will go again to open report and click on outer loadings. Now I have removed IR6. Now all the values are in green. So that means we are fine. Our factor loadings are perfectly fine. After that, we move towards construct reliability and validity. First, we checked outer loading. Outer loadings are in green, so it's fine. After that, we move towards construct reliability and validity. Here, quality criteria. In quality criteria, you will find construct reliability and validity. I click here. Now, all the values are green. So these values have a particular meaning. Means Cronbach alpha must be greater than 0.7. Composite, same goes with composite reliability or AVE, average variance extracted. So all these values are greater than 0.7. So these are in green. So that means it's a go ahead. We can move forward to check some other test for reliability and validity. So we have checked for reliability. It is fine. Cronbach alpha is we check the values of Cronbach alpha to find the reliability. So it is a reliable data and average variance extracted for validity. And it is also green. So average variance extracted or validity is also fine. Now, next is discriminant validity. We also check discriminant validity here. We click on discriminant validity, and if we look at this data, it's all in green. So that means the data is discriminant. Each variable, latent variable, is different from other variables. So that means our data is healthy enough to run for the SEM calculations. So once again, what we have done, first of all, we calculate PLS-SEM algorithm, and in PLS-SEM algorithm, we check outer loading. Once the outer loadings are fine, we check reliability and validity. Once reliability and validity are fine, then we move towards discriminant validity. So AVE is also a validity and discriminant validity is also a validity, but they are different from each other. So this validity is actually convergent validity, and discriminant validity is actually checks the check that latent variables are different from each other. So if you guys have any question, please interrupt in between and ask. Okay. Uh, once we are fine with all the values means outer loadings here, construct reliability and validity and discriminant validity. This discriminant validity is actually HT-empty ratio. There is another method which is Fornell-Larker criterion. If we click on this Fornell-Larker, it shows another way. Same, it is showing discriminant, but through another method. Here the way to interpret the data is that the value of this value of IR must be greater than all these values. If this value is greater than all these values, that means that IR is discriminant from other variables. Same goes with this knowledge hiding. KH stands for knowledge hiding. If this value is greater than all other values, that means discriminant is established. Here also it's 0.88. 0.88 is actually greater than 0.31 and 0.57. So that means discriminant is also established. Same goes with SO and same goes with task procrastination. So these vertical values must be greater than these values. And if these values are greater, then we can say that our data is discriminant. So the point is that you either report both HTMT here, HTMT for discriminant, or you will report Forner lacquer as well. And in some cases, we just only report one criteria, either HTMT or either Forner lacquer. So if you check these all these points, then you can say that your data is fine and data is healthy enough to run PLS-SEM. So so what we do here, we will click here on Excel like this. Now what this point will do, I'll click here on export. This will generate a actual file for all the results of PLS-SEM algorithm. So it's RAR test. I will name this I will call this RAR test measurement model. Okay, so we have checked here the measurement model or a questionnaire validity and reliability. So now it is exporting all the values. It takes time. So now we have export the file. We click on an Excel file and Excel generate this file. So this wonderful file actually explains all those tests. Now the benefit of creating this file is that now I can share this file with any of my colleague who is working with me on this project. Let's say I want to check, let's say outer loading. I will click here, show. Now these are the outer loading. So here also it is showing that data is in green, so that is fine. So actually what this file has done, it has created these results that we checked before in a Excel file. Now once these are created in Excel file, so it becomes very much easy. I just need to copy these results to my actual data file or wherever I need to report these results. So here we have done with measurement model. So till now, if you guys have any question, please ask. Please feel free to ask.
I mean, your section is very interesting. Seriously, it's very interesting. Very, very interesting.
Oh, thank you so much. All right. So now we have checked measurement model. Now we actually going towards the structural model. Means we are going to find the results of our hypothesis. Now for your ease, what our hypotheses are: supervisor ostracism leads towards self-esteem, threat to self-esteem, and that self-esteem leads towards task procrastination and knowledge hiding with the moderation of IR. We will discuss moderation later. Here, first of all, we will discuss the direct relationship. Like supervisor ostracism has impact on threat to self-esteem. Threat to self-esteem has impact on knowledge hiding, and threat to self-esteem has impact on task procrastination. So now we know that our measurement model is fine enough, it's perfectly fine to go towards to check the hypothesis results, which is the real purpose of doing this whole exercise. So to find this again, we have to click on calculate, and then we go for bootstrapping. Okay, so in previous session we have done PLS-SEM algorithm, but here now we go to check the hypothesis. We click on bootstrapping. We click on bootstrapping. Normally it looks like this. Subsample. There is a general rule of thumb. General rule of thumb is we type here 5,000 sample, and confidence interval we change it to bias corrected accelerated BCA. Okay, and our significance level is 0.05. So this research is for management sciences or a business students. So here we usually take a significance level of 0.05. And once we have set these criterias, we click on start calculation. Okay, now I'm going to click on start calculation. So it is calculating. Just take few seconds. Okay, so now we are done, and we have run successfully PLS-SEM equation. Now I will click on open report. I'll click here, open report. Now report is open. So first of all, I have to check the path coefficient. Path coefficient means the relationship between independent and dependent variables. Here, when I go for path coefficient, path coefficient checks the direct relationship. Direct relationship means the relationship between SO and SE. Also, there is a direct relationship between SE and knowledge hiding. There is also a direct relationship between SE and task procrastination. So these are our actual interest. So I click on path coefficient. So first is again 1 second. SO and SE. This is first path. SO and SE. It has impact of 0.317. We look at the original sample and check it has 0.317 impact. SO, if you change a 1 unit of SO, it will change 0.317. It will bring change of 0.317 in SE. And whether this impact or this change is significant, we can find it through p-values. P-values are 0.005. So if the p-value or probability value is less than 0.05, then we can say that this relationship of SO and SE, mean supervisor ostracism, leads towards threat to self-esteem. Then it is a significant relationship and it has an impact of 0.37. Same goes with other relationship like SE and TP. Threat to self-esteem has significant because it is less than 0.05, so it has significant impact on task procrastination, and its value is 0.574. And same goes with other variables. So these are our direct relationships. Once you have checked your direct relationship, then we go for specific indirect effect. If there is a mediation in your path, what is mediation? I'll go back. This is called mediation. Means supervisor ostracism has impact on knowledge hiding with the mediating role of threat to self-esteem. Again, this path is also mediating. Threat to self-esteem has uh, there is a mediation of threat to self-esteem between supervisor ostracism and task procrastination. And to check this mediation, we go to open report and click on specific indirect effect. This point. Now, if I click here, specific indirect effect. So it is showing the mediation of supervisor ostracism on uh, on knowledge hiding with the mediation of threat to self-esteem. It has significant effect because it is less than 0.05 and this impact is 0.101. Now supervisor ostracism has impact on threat to self-esteem and that has impact on task procrastination. This effect is 0.182 and it is also significant. So we can say that these are our mediation. So again, PLS-SEM calculates all the paths, but we have to report